Hi guys, this is Ramzan and you all are welcome to the third video of this coordination compounds. In this video, we will discuss about the IUPAC nomenclature of coordination compounds. In the last video, we discussed about some of the basic terms related to the coordination compounds such as central metal ion, ligands, counter ion, and in that we left two more extra terms. One is complex ion and one more is coordination number. So in this video, we will start with those two basic terms. First one is complex ion. So let me explain this complex ion with the help of examples. Here I have a copper 2 plus ion. When this copper 2 plus ion combines with a 4 neutral ammonia molecules, it is going to form a complex. So here this complex is having a charge on it. Similarly, we have one more example. So when this Fe2 plus ion combines with 6 Cn minus anionic ligands, it is going to make a complex which carries negative charge over here. Now the question is, what is this complex ion? So here complex ion is nothing but what? The electrically charged species formed when central metal ion combines with a fixed number of ions or neutral molecules. So whatever the product formed, that is what we call it as complex ion. Here we have the definition for this complex ion. See, it is an electrically charged species formed when central metal ion combines with a fixed number of ligands. So that is what we call it as complex ion. Next one is, remember this, complex ions are always indicated by the square brackets, and complex ion may be cation or anion. Here we have two complexes. One is cationic complex and one more is anionic complex. This is all about complex ion. Next one is coordination number. This already we discussed in the previous video. Here we have the complex, that is potassium hexacyanoferrate. So in this complex, the potassium is present outside of this square bracket, therefore it is called as counter ion, and this square bracket which encloses central metal ion and ligands is called as coordination sphere. In this complex, Fe is the central metal ion and Cn is the ligand. Here one more extra term, the number outside of this bracket within the square bracket. So this number denotes the coordination number of this metal ion in this complex. Now we have the definition here. So coordination number is nothing but what? It is the total number of monodentate ligands which are directly attached with the central metal ion. We will see some of the examples for it. Here I have a copper complex. In this copper complex, there we have 4 ammonia ligands. So therefore this 4 indicates the coordination number of this copper metal. Here we have coordination number 4. Similarly, we have one more example. This cobalt complex has 2 ligands. There are 2 different ligands. One is ammonia and one more is chloride ligand. So the coordination number of this cobalt in this complex is 6. Why? Because there are 2 different ligands and 3 plus 3 is 6. Next one is, we have Fe-EDTA complex. So in this EDTA complex, this EDTA does not contain any number outside this bracket. It does not mean that the coordination number of iron in this complex is 1, but actually the coordination number of iron in this complex is 6. Now the question is why? So here EDTA is a hexadentate ligand. So each EDTA molecule can make 6 coordinate bonds with the central metal ion. Therefore the coordination number of iron in this complex is 6. Similarly, we have 2 more examples. One is aluminum oxalate complex and one more is ethylene diamine cobalt complex. So here these 2 complexes have the same number of ligands. So it does not mean that these 2 complexes have coordination number 3. So here also the coordination number of aluminum as well as cobalt in this case is 6. It is because here oxalate and ethylene diamine both are bidentate ligands. Therefore the coordination number of aluminum and cobalt in these 2 complexes is 6. So one more important point is, coordination number is always determined only by the what number of sigma bonds formed by the ligands with the central metal ion. Pi bonds, if present in the complex, are not counted or considered for this purpose. Only we have to consider the total number of sigma bonds with the central metal ion. Next one is nomenclature of coordination compounds. The rules recommended by the International Union of Pure and Applied Chemistry for naming these coordination compounds are as follows. Now we will discuss those rules one by one here. First one is order of naming the ions. If I consider a simple ionic compounds like NaCl, we write the name of ionic compound NaCl as sodium chloride. We don't call it as chloride sodium because always we are writing the cationic name first and then followed by the anionic name. The same rule is also applied for naming these coordination compounds. So in coordination compounds, we have mainly two types of complexes. One is ionic complex and one more is non-ionic complex. So ionic complex means this complex may contain either positive charge or it may contain negative charge. So whenever we are going to write the name of such a ionic compounds, in such case we have to follow this rule. Here first we have to write the name of cation and then we have to write the name of anion. In between those two we have to leave a single space. Next one is when it comes to non-ionic compounds are those which do not carry any kind of charge on them. They may also called as neutral ligands. So here neutral ligands are always written as one word. Whenever we are going to write the name of such a neutral ligands, so there we write it as just one word. Let's see some of the examples for these ionic compounds as well as for the non-ionic compounds. So here I have two complexes. One is this potassium hexachloroplatinate and one more is cobalt complex. So here in this potassium complex, the potassium is present outside of the square bracket. So when this complex is dissolved in water, it gets split into K plus and PtCl6 2 minus. So means it gives two kinds of ions. One is cation and one is anion. Here cation is simple cation and anion is here it is complex anion. So now the name of this complex we can write it as, first we have to write the name of cation and then we have to write the name of anion. So the name of this complex is potassium hexachloroplatinate. Similarly we have a cobalt complex. So in this case when this cobalt complex is dissolved in water, it gives again two ions. One is complex ion and one more is simple ion. But in this case this complex carries a positive charge and this simple ion carries a negative charge. So first we have to write the name of this complex ion and then we have to write the name of this anion. So the name of this complex is pentamine chlorido cobalt chloride. There I left the space between this chloride and this complex cation. So when it comes to the non-ionic compounds, here we have two examples. So these two complexes do not have any kind of charge on them. So whenever we are going to write the name of such a compounds, just we'll write it as just one word. So here we have the name tetramine dichlorido nickel and in this case diamine dichlorido platinum. This is all about what order of naming the ions. Next we will move on to the second rule, that is naming of coordination sphere. So here coordination sphere is nothing but what? The square bracket which encloses central metal ion and fixed number of ligands. This is called as coordination sphere. So while writing the name of this coordination sphere, always we have to follow this LCO rule. Now what is this LCO rule? So here L stands for name of the ligand in alphabetical order, C stands for name of the central metal ion and O stands for oxidation state of metal ion in Roman numerals. This means whenever we are going to write the name of oxidation state of central metal ion, always we have to represent it in the Roman numerals. So here we have the sequence of writing this name of coordination sphere. So first we have to write the name of the ligand. After that we have to write name of the central metal atom and then followed by the oxidation number of the central metal ion in Roman numeral. Always remember this sequence while writing the name of this coordination sphere. This is all about the second rule. Next we will move on to the third rule, that is naming of ligands. So as we already discussed in the previous video, ligands are classified into three types based on their charge. So we have anionic ligands, cationic ligands and neutral ligands. So first we will discuss anionic ligands. Anionic ligands are those ligands which carries negative charge on them. So when it comes to naming the ligands, anionic ligands, we have to follow the rule here. All the anionic ligands names are obtained by replacing the last letter E by O. Here we have some examples. So here we have the anion fluoride. In order to make it a ligand, what we have to do? We have to replace this ending E by O so that it becomes fluorido. Similarly, chloride becomes chlorido, cyanide becomes cyanido, and hydroxide becomes hydroxido, and oxalate becomes oxalato. So there we have the rules how to write these anionic ligands. So see, this we already discussed in the last video. Whenever the anionic ligands which are ending with IDE, there we have to replace this ending V E by O in order to make it IDO. Similarly, we have certain anionic ligands which are ending with ITE. For example, nitrite, sulfide, phosphide. In such case, we have to replace this E by O in order to make it as a ligand. And there are certain ligands which are ending with ATE. For example, sulfate, phosphate, nitrate. So in order to make them as a ligand, there we have to change this E by O so that it becomes ATO. This is what the rules of writing the anionic ligands. Next one is neutral ligands. So these neutral ligands do not have any special names. So here whenever we are going to write the names of these neutral ligands, just we write it as their parent molecule. Here we have certain examples. And one more thing, remember, neutral ligands are always having lone pair of electrons on them for the donation. So we have nitrogen, this is simply called it as dinitrogen. Oxygen, it is dioxygen. BPY is called as bipyridine. PS3 is called as phosphine. PPS3 is called as triphenyl phosphine. And CS3NS2 is methylamine. And again we have more number of examples over here. We can go through all these examples. But there are certain exceptions while writing the names of these neutral ligands. We will see those exceptions over here. So there are only these 5 ligands which are having special names. So ammonia is called as amine. It is always written as amine. And remember, whenever we are going to write amine, there we have to write double M. And CO is written as carbonyl, CS is written as thiocarbonyl, water is written as aqua, and NO is written as nitrogen. Remember these 5 exceptions while writing the names of neutral ligands. Next we will move on to the positive ligands. Positive ligands are those ligands which are having a positive charge on them, and these ligands are having a suffix IUM. Here we have certain examples. NO plus is called as nitrosonium, NO2 plus is called nitronium, and NS2 NS3 plus is called hydrazinium. So far we have discussed the 3 rules of this naming coordination compounds. Remaining the rules we will discuss in the next video. Thank you for watching this video.